Hello, ladies and gentlemen. Welcome back to Power Vacuum. I'm your host, Belmont, and I'm coming at you with a little bit of a different video today. It's kind of in the realm of entertainment. It's comic book related, as some of you may have read from the title, or you can see on the screen here. I'm on phys.org, phys.org, which is physics-based stuff. This is a chemistry thing. And as you can see, inspired by Spider-Man. That's the entertainment aspect coming in. Researchers, I'm fucking up right off the beginning. Researchers recreate web-slinging technology. And here's a shot of it. And this is a wild story. I'm just going to jump right in because it's pretty crazy and I want to read it. A liquid stream of silk solution solidifies to a fiber, adheres to and lifts a glass laboratory beaker. Right there. Every kid who has read read a comic book or watched Spider-Man movie has tried to imagine what it would be like to shoot a web from their wrist, fly over the streets, and pin down villains. Researchers at Tufts University took those imaginary scenes seriously and created the first slinging technology in which a fluid material can shoot from a needle, immediately solidify as a string, and adhere to and lift objects. The study is published in journal Advanced Function Materials. These sticky fibers created at the Tufts University Silk Lab come from silk moth cocoons, which are boiled in a solution and broken down into their building block proteins called fibroin. Or is it fibroin? I think it's fibroin. The silk fibroin solution can be extruded through narrow bore needles to form a stream that, with the right additives, solidifies into a fiber when exposed to the air. This is just super cool. Of course, nature is the original inspiration for deploying fibers of silk into tethers, webs, and cocoons. Spiders, ants, wasps, bees, butterflies, moths, beetles, and even flies can produce silk at some point in their life cycle. Really? Ants? I didn't know ants could do that. I guess that's what their eggs are made of. Nature also inspired the Silk Lab to pioneer the use of silk fibroin to make powerful glues that can work underwater, printable sensors that can be applied to virtually any surface, edible coatings that can extend the shelf life of produce, a light collecting material that could significantly enhance the efficiency of solar cells, and more sustainable microchip manufacturing methods. Okay, light collecting, I was thinking light as in like low weight, but they meant actually like photovoltaics. However, while they made significant progress with silk-based materials, the researchers had yet to replicate the mastery of spiders, which can control the stiffness, elasticity, and adhesive properties of the threads they spin. What is this video of? We're going to watch this quick video. This is various silk experiments with the needle. And I guess depending on the amount of solution mixed in with the fibroin, depends on how it came out. Like, too much. Oh, battery low warning. Hang on a second. Notebooks, y'all. Notebooks. But in a 120 solution, it's like almost a mist, and 90 it like instantly clumped, and then like the lighter the solution got, the more control they had. Where you can see 45 looks like the sweet zone, because this just shoots out as a wild web. But a breakthrough came about purely by accident. What I love about that statement is most of the major scientific advancements that have moved humanity into like the next age of understanding and science and reason were typically accidents. They were experimenting with one thing, accident happened that had a interesting result, and they ran with it. I know right now they're working on a cancer drug that one of the side effects that they've noticed in patients is that their hair returns to its natural color. So when like they're older people whose hair has turned white, they've started growing their natural hair color again. Like people with black hair grew black hair. People with red hair, their hair was turning red again. It's a very fascinating side effect that they're not trying to do, but it's just a side effect. Have a complete accident, which could be the new, major craze for people. Instead of, having to dye their hair, they just take this pill, boom, and their hair's back to its original color. But I'm rambling. Where are we at? Came purely by accident. I was working on a project making extremely strong adhesives using silk fibro-in, and when I was cleaning my glassware with acetone, I noticed a web-like material forming on the bottom of the glass, said Marco Lopresti, research assistant professor at Tufts. The accidental discovery overcame several engineering challenges to replicate spider threads. Silk fibro-in solutions can slowly form a semi-solid hydrogel over a period of hours when exposed to organic solvents, like ethanol or acetone. But the presence of dopamine, which is used in making the adhesives, allowed the solidification process to occur almost immediately. When the organic solvent wash was mixed in quickly, the silk solution rapidly creates fibers with high tensile strength and stickiness. Dopamine and its polymers employ the same chemistry used by barnacles to form fibers that stick tenaciously to surfaces. This next step was to spin the fibers in air. The researchers added dopamine to the silk fibro-in solution, which appears to accelerate the transition from liquid to solid by pulling water away from the silk. When shot through a coaxial needle, a thin stream of the silk solution is surrounded by a layer of acetone, which triggers the solidification. The acetone evaporates in mid-air, leaving a fiber attached to an object it contacts. The researchers enhanced the silk fibro-in dopamine solution with chitosan, or chitosan, not sure how to pronounce that, a derivative of insect exoskeletons. Okay, exoskeletons. That's a hotly debated subject on how this is chitin versus chitin or chitin. So I'm going to go with the goofy sounding one because this is all some crazy goofy stuff. Chitosan. A derivative of insect exoskeletons that gave the fibers up to 200 times greater tensile strength. And borate buffer, which increases their adhesiveness about 18-fold. Just say 18 times, guys. Or would that be 17 times because of the way folding works? I'm not sure. The diameter of the fibers could be varied between that of human hair to about 0.5 millimeter, depending on the bore of the needle. The device can shoot the fibers that can pick up objects over 80 times their own weight under various conditions. The researchers demonstrated this by picking up a cocoon, a steel bolt, a laboratory tube floating on water, a scalpel partially buried in sand, and a wood block from a distance of about 12 centimeters. They say scalpel, it's just a scalpel blade, which I guess technically is the scalpel. I always considered a scalpel the whole tool, but I suppose the handle is a separate thing. But here's the video. So they shoot the liquid solution. Right, then they stop and add the, it takes a second for the acetone to pump through, but look at this. Look at this. They are shooting web. They are effectively shooting web to an object and picking it up. This is some straight up science fiction, Marvel Comics fantasy bullshit, and I love every second of it. Like Spider-Man IRL, you damn right, because like the minute they perfect this, then they're going to start seeing how far the stream can go before it solidifies. How far can you like make a super soaker with this? Or God, what spider was it? 2099? Is it 2099? Oh no, you know what it was? The Spider-Man from Amalgam Comics. What was his name? Spider-Boy. He had a gun that fired webbing. Instead of shooting web shooters, he had like a gun that he shot and swung with it. How far away are we from that? Where was I? Yeah, here we go. Lopresti noted that if you look at nature, you will find that spiders cannot shoot their web. They usually spin the silk out of their gland, physically contact the surface, and draw out the lines to construct their webs. We are demonstrating a way to shoot fiber from a device and adhere to pick up an object from a distance. Rather than presenting this work as a bio-inspired material, it's really a superhero-inspired material. Natural spider silk is about 1,000 times stronger than the man-made fibers in the study. But with a little added imagination and engineering, the innovation will continue to improve and pave the way for a variety of technological applications. As scientists and engineers, we navigate the boundary between imagination and practice. That's where all the magic happens, said Fiorenzo Ominetto, Frank C. Doble, professor of engineering at Tufts University and director of the Silk Lab. The Silk Lab just sounds like, what a cool place to work. Where do you work? The Silk Lab. We can be inspired by nature. We can be inspired by comics and science fiction. In this case, we want to reverse engineer our silk material to behave the way nature originally designed it and comic book writers imagined it. That's it. That's the end of the article. How cool is this? Shooting webbing. And just think, if they manage to figure out how spiders make their web so strong and then apply it to this, you're literally going to be able to do Spider-Man shit. Now, the biggest problem with Spider-Man is that we don't have the excessive amount of strength that he has, because the real issue with jumping off a building and swinging is you would most likely dislocate your arms because your body weight coming down from gravity and then suddenly snapping and stopping. I mean, what happens with Gwen Stacy would happen to a lot of people. That sudden stop would wreck your body. Most likely, like I said, if you're swinging from your arm, it's going to dislocate your shoulder, maybe your elbow, maybe break some bones in there, probably cause some spinal damage. But, imagine like this being employed by like law enforcement to fire like an actual web at somebody. Oh, you're running from the cops, psh, web shot, you're stuck to the ground. That's probably the real application. That's going to be military use. But I just thought this was crazy cool. I couldn't not talk about it. And like I said, it's somewhat entertainment related. There's another science thing I saw that blew my mind. I might talk about that. So you might hear from that in the future, because I do have a lot of science stuff I look up, and I read a lot of stuff about physics and chemistry just because it interests me. That's why I, even though I have a major in English, that's why I also studied business law and world religion when I was in college, because they interest me. And, I didn't really know what I wanted to do. I was like, oh, which way am I going to go? Ended up in the English path. And, yeah, well, whatever. That's a useless degree unless you explicitly want to teach, by the way. But, hey, Spider-Man webbing just around the corner, it seems. Complete accident. From accident to science fiction. From science fiction fantasy to science fiction, to science fact. Well, that's all I have for this video. Belmont out.